So from the Werner's theory we came to know that there were many such limitations which were retarding the Werner's theory. In order to overcome that Werner's theory limitations, a new theory was popped up, and that was called as VBT, which means valence bond theory. So according to this theory, it mainly used the concept of the hybridization in order to explain that why the molecules or why the complexes are having a specific geometry. According to it, its first postulate states that whatever your central metal atom or the ion is there, it first provides the vacant orbitals in order to form the coordinate bond. Here it is specifically mentioning the type of the bond, which Werner theory failed to explain why the molecules are having the directional properties. But VBT was able to explain that the directional property is mainly because it is forming a coordinate bond with respect to your ligands. So central metal atom or the ion providing the vacant orbitals to form the coordinate bond with the ligand. The second major postulate explains that whatever these vacant orbitals are there, they will undergo hybridization. Hybridization to give the vacant hybrid orbitals. Vacant hybrid orbitals. You can ask me, so why it has to undergo hybridization? Because you just remember guys, here they have said that it could be a vacant orbitals. So the vacant orbital can be S, the vacant orbital can be P, the vacant orbital can be D. But when you are seeing individually, we know that they are all having the different energies. But when they undergo hybridization, the main concept of the hybridization is all these orbitals will combine to give you the one energy orbital. So all the orbitals will be having now, all the vacant orbitals will be having the same energy. That is the reason the vacant orbitals undergoes the hybridization. Majorly the next important question arises that what would be the number of the vacant orbitals which would be provided. So we also explained that the vacant orbitals provided will be equal to its coordination number. That is, what is the number of the ligands which are coming and attaching to your central metal atom or the ion, that much number of the vacant orbitals will be provided. The next much important thing was with respect to the geometry. Of course, when I said with respect to the Werner's theory, I written two types of a geometry. So this was actually a square planar, whereas this was actually a tetrahedral. Of course, Werner Philip was not able to explain that in this complex UNH347, which among these two can have a geometry. Of course, only one can exist. But VBT was very much particular about the geometry. He says that the geometry mainly depends upon the hybridization your vacant orbitals are undergoing. That is, in the diagram you could just see that if the coordination number is 4 and the type of hybridization is sp3, the geometry is your tetrahedral. In the same case, if the coordination number is 4 and the type of hybridization is dsp2, it is your square planar. If the coordination number is 5, the type of hybridization is sp3d, it is trigonal bipyramidal. If it is 6, you are having sp3d2, it is octahedral. d2sp3, it is also an octahedral. Now the major question arises, if you could notice over here in the octahedral, basically you could just see that I have written sp3 d2 and d2sp3. So you can ask me, sir, both looks alike, but the major thing over there is the first one, it will be called as an outer orbital complex, whereas the second one will be called as an inner orbital complex. You can ask me, how is it? Let us come with that. So first of all, inner orbital complex means what? In a complex, if central metal atom or the ion uses its inner n-1d orbital for the formation of the bonding, it will be called as an inner orbital complex or spin paired or low spin complex. you'll be able to see in our next examples. So you have to just remember that inner orbital complex means it is using its inner n-1d orbitals for the complex formation, whereas the outer orbital complex means what? It is utilizing its outer nd. You can mention over there, I mentioned over there as nd orbital for the formation of the bonding. So that will be called as what? Outer orbital complex, or a spin free, or a high spin complex. So I have given you the examples. Don't worry for now, don't get confused. We will be dealing with it in our further examples.